bonus coverage for homework. On E, M is the midpoint of PR and QS. So if M is in the middle of PR, remember midpoint cuts it into two equal parts. If you were doing a proof, which you don't have to on these, we would put by definition of midpoint, PM equals RM. Then we also know, since it's the midpoint of QS, we know that MS is congruent to MQ by definition of midpoint. If we look up here now, we have some triangles that we can look at, and because we're dealing with these diagonals, we would be able to look at some congruent triangles, but not the ones we're used to. We have some vertical angles going on here, so this matches that. And let's stop right there for a second. I know, and this isn't very formal, but that the MQ triangle is congruent to the, now watch your order, P to M to Q. That's going to be congruent to RMS. Now, that is, of course, by side angle side. If I were doing a full proof on this, I would need to talk about what sides are congruent and what angles are congruent. This, of course, the angle is congruent by vertical angles. And these sides are congruent by definition. So the definition of midpoint. So again, I'm not organizing it in a two-column proof, partially because I know they're scary for you, but also because the definition of midpoint and vertical angle theorem, as long as you have them explained, that's 90% of the battle. So I've got the two sides explained by the definition of midpoint and the angle explained by vertical angle. So since those are congruent, guess what that says about PQ and RS? They're congruent. So PQ is congruent to RS, and that is by our favorite abbreviation, CP-CTC. The congruent triangles have corresponding parts that are congruent. The outside part is equal. Now, the same thing is going to follow. We've got lots of writing going on over here. But the side triangles are also going to be congruent. So we could say triangle PMS is congruent to triangle RMQ. Those are congruent here because this angle also is vertical to this one. So the same explanation would follow. My angle, and this is by SAS again, my angle is congruent because they're vertical, and my sides are congruent by the definition of midpoint. So I'm just going to leave that here. That's all over the place. So now we know the triangles are congruent, so we can state that PS is congruent to SQ. Nope, sorry, RQ. P to S is congruent R to Q. There we go. By saying that, if we mark these on here, I got to use 4 hashes now. Those are congruent by CPCTC again. And now we are done, because the other day we've already proven if opposite sides are congruent on a 4-sided figure, it's guaranteed to be a parallelogram.